Welcome to question 8 of the 2008 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So every Friday Jean-Paul goes to see a movie. He always goes to one of two local cinemas, the Dandy or the Chino. If he goes to the Dandy on one Friday, the probability he goes to the Chino the next Friday is 0.5. So we'll start by just summarising that piece of information. So if he goes to the Dandy to start with, the probability that he'll go to the Chino the next Friday night is 0.5, which I'm going to write as 5/10. That means the probability that he'll go back to the Dandy is also 5/10. We also have, if he goes to the Chino one Friday night, then the probability he goes to the Dandy the next Friday night is 0.6. So if he goes to the Chino one night, the probability he'll go to the Dandy the next night is 6/10, meaning the probability he'll go back to the Chino is 4/10. On any given Friday, the cinema that he goes to depends on the cinema he went to on the previous Friday. So if he goes to the Chino one Friday, we are asked what is the probability that he goes to the Chino on exactly 2 of the next 3 Fridays. So we know that he has gone to C on the first Friday. From there, he could go back to C or on to D. So from C to C, we can see there's a 4/10 chance of that happening, and from C to D, there was a 6/10 chance of that happening. Now, we're not going to fill out the full tree, we're just going to look at the branches that will result in him going to the Chino on exactly 2 of the next 3 Fridays. So if he goes to C on the first one, he could go to C on the second or to D. So from C to C is 4/10 as a probability, and from C to D is 6/10. And then if he's gone to C on the next 2, then we only need to consider the chance that he goes to D on the next Friday. And that's going to be from C to D, 6/10. If he goes to C, then to D, then he must go to C again, so we're only going to consider that branch. And going from D to C is 5/10. And finally, if we look at the last way he can go to C on exactly 2 of the next 3 Fridays, if he goes to D, then he must go to C and to C again. So from D to C, if we look at what we summarised before, that's 5/10. And to go from C to C, that's 4/10. So what we need to do is work out what this probability will be. So the probability that he goes 2 of the next 3 is equal to the probability that he goes C, C, D, plus the probability that he goes C, D, C, plus the probability that he goes D, C, C. So from the tree diagram, we can work out what those probabilities will be, which is 4/10 times 4/10 times 6/10. And then the probability he goes C, D, C is 4/10 times 6/10 times 5/10 if we go along that branch. And lucky last, if he goes DCC, then it is equal to a 6/10 times 5/10 times 4/10. So simplifying these down, we have 4 times 4 is 16 times 6 is 96/1000, plus 6 times 5 is 30 times 4 is 120/1000. And then the second one is also 30 times 4 is 120/1000. So simplifying that, if we add those 3 fractions together, we get 336/1000. And that can simplify down to be 42/125 when simplified. So that is the probability that he will go to the Chino on exactly 2 of the next 3 Fridays. So from the examiner's report, we can see that about 40% of students received full marks, and nearly all students drew a tree diagram. However, a simpler approach would have been to only write down the 3 appropriate choices, or list all possibilities and then select the 3 required. Some students were unable to assign correct probabilities, and a number had difficulty completing the calculations correctly. A small number of students thought that the binomial distribution applied to this question.